Here is the next example. In this example, he's asking us about finding the current passing through this 15 kilo ohm, which is I. He's also asking us to find V naught. Okay, so step 1, find the voltages at all the outer nodes. Outer is nothing but the node which is going to the other part of the circuit, which is not shown in this figure. Okay, so I know that voltage is 10, here minus 10, here it is 0 volt. So draw all the possible current flow directions. We know that current always flows from higher potential to lower potential. So that is one possibility. Another possibility from 10 to 0. Okay, and another possibility is 0 to minus 10. Those are the three possibilities. Let me label D1, D2 and D3. So for sure we know that D1, both currents are flowing from anode to cathode, so acting like a closed switch. Okay, and same thing with D2. So if you look at D2, both currents are flowing from anode to cathode, that is also acting like a closed switch. Okay, and D3, now when we look at D3, one current is getting in, another current is going out. I mean, one is flowing from anode to cathode, another one is cathode to anode. So we don't know whether it is acting like a closed switch or open switch. Now step 2, okay, it's up to you. Assume so it's only D3. Assume whether it is acting like open or closed. For time being, I'm going to assume this is acting like a closed. Okay, acting like a closed switch. So sometimes your assumption might be right in the first assumption itself, or first time itself. Then you don't need to repeat step 2 again. Okay, so here I'm assuming it is acting like a closed switch. So if it is acting like a closed switch, the circuit is going to be look like this. Okay, so for sure I can see V naught equal to 0 volts because it's directly grounded. Okay, so my I must be 10 minus 0 over 15k, which is, how much is that? 10 over 15k, which is 2/3, 2 by 3 milliampere, which is 0.67 milliampere, right? So same way, let me label this as I1 for simplification purpose, and I'm going to take to I2 equal to, I know the voltage here must be 0, this is minus 10, so 0 minus of minus 10 over 5k, so 10 over 5k equal to 2 milliampere. Okay, so we're assuming this diode D3 is closed, right? So now our goal is finding I1, which we found, and goal is finding V naught, which we found. Now verify. Step 3, verify. Okay, how do we verify? So if we look at D3, okay, we're assuming this diode is acting like a closed switch. Is there any current passing through the diode? We'll verify that. So if you look at here, apply at V naught, apply KCL. Okay, so if apply KCL, I1 current is coming in and I2 is going out. Let me label this current is also going out, which is I3 plus I3. I1 I know, which is 0.67, equal to I2 we know, which is 2 milli. I3 we don't know, so based on this, I3 equal to minus 2 plus 0.67, so which is minus 1.8 33 milliampere. So that indicates that I'm saying I3 is flowing from V0 to ground, but in reality that is flowing in opposite side. So we're saying there is 1.33 milliampere flowing from cathode to anode, which is not possible. So here our assumption is wrong. So the previous 2-3 examples, it was easy to prove that the diode, our assumption is wrong or right. But in this example, I have to do extra step by applying KCL at V0. Okay, so you need to verify your assumption is right or wrong. So you can do it many ways, like applying mesh analysis, nodal analysis, or a simple series, a simple current flow direction. Okay, now, so our assumption is wrong. What it should be, it must be, probably it is acting like an open switch. So based on this, I can find I equal to 10 minus of minus 10. So this voltage minus this voltage divided by these two are in series, which is 20k. So 20 over 20k, which is 1 milliampere. Okay. Once I have 1 milliampere let me find V0. Our V0 must be, I know this current, which is 1 milliampere, we just found. What is the voltage drop must be? 1 milli times 15k, there must be 15 volt. Okay, so 10 minus V0 must be equal to 15 volt, and V0 must be negative 5 volt. Okay, so the voltage at this point must be negative 5 volt. Okay, so he's asking for V0 as well as I found those two quantities. Now step 3, again we are repeating step 3, we're going to verify. So here is our D3, diode D3. The voltage at this point is minus 5 volt and this point is 0 volt. So your cathode voltage is higher than the anode voltage, and we are assuming this is acting like open switch. Yes, our assumption is right. Okay, so this is the right answer. Okay, I'll stop this video here. Next video I'm going to solve another similar kind of example. Thank you.